I won the Fields Medal in 1970. I have spent 60 years inside mathematics. I have trained hundreds of students at Harvard, at Kyoto, at Columbia. I have seen young minds light up with understanding. I have seen brilliant students quit. I have seen mediocre students become extraordinary through sheer force of will. I know what talent looks like before it knows itself. In 2007, I was invited to Seoul National University as a visiting professor. I was 76 years old. I had agreed to teach a course in algebraic geometry, my own work, singularity theory, the problems I was still struggling with in real time. A student walked in. He was in his 6th year of college. He had failed courses. He had no research background. His transcript was, by every conventional measure, a disaster. He told me later that he had not come to learn algebraic geometry. He had come because he heard I was famous and wanted to see what a famous mathematician looked like up close. I did not care why he came. I cared about what happened next. His name was June. He was born in 1983 in Stanford, California, while his parents were completing their graduate studies. His father would become a professor of statistics at Korea University. His mother, a professor of Russian language at Seoul National University. The family returned to South Korea when he was 2 years old. He grew up in a household of academics, books everywhere, ideas everywhere. And he hated school, not disliked it, hated it. The routine, the memorization, the rigid structure of a Korean education that demanded perfection in every subject, every test, every hour of every day. His test scores in mathematics were, in his own words, notably mediocre. On some tests, he did reasonably well. On others, he nearly failed. His teachers concluded what seemed obvious. This boy did not have the aptitude for mathematics. And for many years, Jun-ha believed them. By 16, he was exhausted. The Korean education system is relentless, with 14-hour study days, cramming after regular school, and tests that determine everything. Jun-ha looked at this system and said, no. He dropped out of high school, not to pursue mathematics or any science, but to become a poet. He wanted to find beauty on a page, to create something from nothing, to express what he felt about the world in language that mattered. Poetry, he believed, was the art of making the invisible visible. He did not yet know that mathematics could do the same thing better. Eventually, he returned to formal education. In 2002, he enrolled at Seoul National University. He chose to study astronomy and physics, not because he was passionate about either, because he did not know what else to do. He skipped classes. He failed courses. He had to retake several of them. 6 years passed. 6 years is not a gap year. It is not a detour. In a system that expects you to graduate in 4, 6 years is a statement. It says, this person is lost. And Jun-ha was lost. I didn't know what I wanted to do, he said later. I didn't know what I was good at. He was 24 years old, still an undergraduate, still drifting, still searching for the thing that would make his mind come alive the way poetry once had. And then he walked into my classroom. I did not teach a normal course. I never have. Most professors deliver material that has been refined over centuries, clean proofs, elegant arguments, everything polished, everything already solved. I refuse to do that. I walked into my lectures and talked about the problems I was working on that week, that day, sometimes that morning. Singularity theory, resolution of singularities, problems I had not yet solved, proofs I was not sure were correct. Basically, he lectured about what he thought about yesterday, Jun said later. The other students were confused. Many dropped the course. The material was too raw, too uncertain, too far from what a textbook would give them. Jun-ha did not drop the course. He sat in that room, and for the first time in his life, he saw what mathematics actually was. Not the memorization of formulas, not the repetition of techniques someone else discovered 200 years ago, but the act of standing at the edge of what is known and reaching into the dark. The suspense of not knowing, the freedom that comes with uncertainty, the surprise that becomes possible only when you abandon the need for an answer. He had been looking for this his entire life, in poetry, in writing. "I found that mathematics could give me what poetry could not," he said. "The ability to search for beauty outside myself, to try to grasp something external, objective, and true." I noticed him immediately, not because he was brilliant, not at first, but because he was still there. Week after week, when the room grew emptier, he remained. And then the questions started. They were not the questions of someone who had studied mathematics for years. They were not technical. They were not sophisticated in the traditional sense. They were strange. They came from an angle I did not expect. I took him on as a student. We would travel together to Japan, to conferences, and he would absorb everything around him. This was a man who 5 years earlier had been writing poetry alone, convinced that mathematics was not for him. Now he was asking questions that my colleagues at Harvard had not considered. I wrote him a letter of recommendation. I put everything I had into it. The full weight of a Fields Medal behind a student with a failing transcript. He applied to about a dozen graduate programs in the United States. Every university rejected him, every single one, except the University of Illinois at Urbana-Champaign, which placed him on a waiting list and, eventually, reluctantly, offered him a spot. Think about that, a man who would go on to win the Fields Medal, the highest honor in all of mathematics, could not get accepted to graduate school. The system saw the failed courses, the 6-year degree, the dropout history, the lack of publications, the absence of every signal the system is designed to detect, and it said no. Jun-He went to Illinois, then he transferred to the University of Michigan, and he began to do work that would shake combinatorics to its foundations. In 2012, while still a PhD student, he solved Reed's conjecture, a problem about chromatic polynomials that had been open for decades. No one could prove it. Proved it. And the method was extraordinary. He did not attack it the way a combinatorialist would. He came through algebraic geometry, my field, the field he had stumbled into by accident in my classroom. He took tools from Hodge theory, a framework designed for studying shapes in higher dimensional geometry, and carried them into a world where they did not seem to belong. The discrete, finite world of graphs and networks and counting problems. It should not have worked. It worked beautifully. The mathematical community took notice. But he was not finished. With Karim Adiprasito and Eric Katz, He turned to the Rota conjecture, open for over 50 years. Everyone believed it was true. The evidence was overwhelming, but no one had the tools to prove it. Jun-He built the tools. He showed that you do not need physical space to do geometry, that the deep truths of Hodge theory, truths discovered in the context of smooth, continuous shapes, apply equally to the jagged, discrete world of combinatorics. "You don't need space to do geometry," he said. That made me fundamentally rethink what geometry is. The proof was published, the conjecture fell, and the mathematical world understood that something fundamental had shifted. On July 5, 2022, the International Mathematical Union announced the winners of the Fields Medal. Jun-He, age 39. The boy who failed math tests in elementary school. The teenager who dropped out to write poetry. The student who drifted for 6 years without direction. The applicant rejected from every graduate school. He stood on the same stage where I had stood 52 years earlier. When asked how it felt, he said that winning can make it hard to be free. When you become aware that others see you a certain way, you tend to act accordingly. He is now a professor at Princeton, He takes long walks through the woods every afternoon, often getting lost. He does not seem to mind. I have spent my life surrounded by mathematicians. The ones who publish early. The ones who win competitions at 12. The ones whose trajectories are straight, whose careers are built on everything the system rewards. And then there was Junha, a boy the system could not see, a mind that did not respond to classrooms or tests or memorization, a person who needed to watch mathematics happen in real time, raw, unfinished, uncertain, before he could understand that it was the thing he had been searching for all along. I did not teach him mathematics. I showed him what mathematics looks like when no one has solved it yet, when the answer does not exist, when you are standing at the edge and there is nothing beneath you but the problem itself. He recognized it immediately, the same way he had once recognized poetry. The system told him he was not good enough. Every transcript, every test score, every rejection letter said the same thing. You do not belong here. He belongs here. He always did.